All right, today we're going to dive deep, and I mean really deep, like 2.5 miles beneath the ocean's surface. We're going into total darkness, where an absolutely impossible discovery is rewriting everything we thought we knew about life, our planet, and maybe even our place in the universe.
So, this all kicks off with a really fundamental question. We're all taught in school that oxygen comes from photosynthesis, right? Plants, algae, using sunlight to create the air we breathe. But what if that's not the whole story? What if there's another way? A kind of hidden electric source of oxygen. It's been humming along in complete darkness for millions of years. The whole story starts with a machine giving a reading that just couldn't be right. Imagine you're deep in the Pacific, in a place with no light and crushing pressure, and suddenly your oxygen sensors just go wild. The first thought? Gotta be a broken machine. So they checked it, they ran it again, and the result was exactly the same. Something down there was breathing life into the abyss. So yeah, this brings us to the puzzle. We're in a place called the Clarion-Clipperton Zone, or the CCZ for short. It's this massive underwater plain bigger than India. And it was right here that scientists stumbled onto a mystery that pretty much defied basic biology. What a team led by marine biologist Andrew Sweetman saw back in 2022 was just astonishing. In just a couple of days, the oxygen levels on the seafloor didn't just show up, they tripled. In a place where there should be basically no oxygen, it was suddenly everywhere. So, where in the world was it coming from?
Well, the answer wasn't biological at all. It was geological. See, the key to this entire mystery wasn't some kind of strange life-creating oxygen. It was something way, way weirder. The rocks themselves, the very seafloor, were generating electricity.
Okay, so meet the source of all this. Polymetallic nodules. These are not your average rocks. They're these ancient metallic formations, kind of like a softball. Some are older than the dinosaurs, and they grow incredibly slowly. We're talking a single centimeter can take millions of years to form. And for all that time, they've just been sitting there, silently generating a small electric charge. So how does this actually work? It's a process called electrolysis, and it's actually beautiful in its simplicity. Each one of these little nodules generates about 1 volt of electricity. Now, seawater is a great conductor, so it acts like a wire, connecting these vast fields of billions of nodules into one giant network. This collective current is just strong enough to split water molecules, H2O, into hydrogen and, you guessed it, oxygen. And that oxygen gets released, creating what scientists are now calling dark oxygen. And just to be clear, this is not some small, localized thing. In the Clarion-Clipperton Zone alone, it's estimated there are 21 times billion tons of these nodules. That is an absolutely mind-boggling number. It's enough to generate a continuous electrical output that could probably power a small city.
But here's where the story takes a crazy twist. This discovery, it isn't entirely new. Get this, back in the 1970s, the CIA found these electric rocks. They were using a deep-sea mining operation as a cover story to go recover a sunken Soviet sub. They found the nodules, studied them in secret, but their findings stayed classified for decades. It was only a few years ago that the scientific community independently rediscovered the whole thing.
So this discovery doesn't just change our understanding of geology, right? It totally revolutionizes our search for life. It challenges the most basic idea that life needs light to even exist. And of course, where you have energy, water, and oxygen, you are going to get life. A survey of this zone in 2023 found over 5,000 different species. And here's the kicker, 90% of them were completely new to science. An entire ecosystem as diverse as anything on the surface, just thriving in total darkness. And living among all of this new life is something that sounds like it's straight out of a sci-fi movie. Electrotrophs. These are microbes that have evolved to just skip eating organic matter altogether. They literally eat electricity, pulling electrons directly from the nodules for energy. It's a completely different way of life.
So what's the big point here? It's absolutely crucial. If life can thrive without any sunlight here on Earth, it means it can do it anywhere. This one discovery potentially expands the number of habitable worlds out there in the universe from billions into the trillions. For decades, our search for alien life has been about looking for planets like ours, in that Goldilocks zone where you can have liquid water and sunlight. But now, the search is totally changing. We can start looking for life on icy moons, like Jupiter's moon Europa.
It has a deep, dark ocean, and it gets bombarded with radiation that could trigger similar chemical reactions. We're not just looking for sunlight anymore. Now, we're looking for electricity. Now, as you can imagine, this has led to some, well, let's call them more controversial theories. Some scientists have proposed that these nodules aren't just random. They think they might form a connected seafloor neural network. The idea is that this massive circuit could generate a planetary electromagnetic field, acting almost like a global brain. Okay, so it is really important to say that most researchers hear neural network and just dismiss it as pseudoscience. But even if that theory is a bit of a stretch, the facts that are established are still game changers. The rocks are electric, and the dark oxygen they make is very, very real. And that reality has led us to a really profound, high-stakes choice. Because these life-giving rocks, they also happen to be a treasure chest. Tucked away inside these nodules are the very minerals that our green economy is absolutely desperate for. We're talking cobalt, nickel, manganese, and copper. All of them are critical for making batteries for electric cars and for storing renewable energy. So this has just sparked an incredibly intense debate. On one side, you have mining companies arguing that we need these nodules for the clean energy transition. They say it's way less destructive than land-based mining, which chops down forests and displaces people. But on the other side, you have scientists warning that deep-sea mining will just obliterate these ancient, unique ecosystems in a matter of days, causing permanent damage and risking a whole chain reaction of consequences for the ocean we can't even predict. This quote really just gets to the heart of the concern. We're flying blind, and we actually have proof of the long-term damage. They've gone back to test mining sites from the 70s, and even after 50 years, the seafloor hasn't recovered. So we're basically making a permanent decision with very incomplete information.
And this brings us to the final and frankly pretty sobering question. By chasing this new gold rush, what are we actually risking? Could we be walking blindly towards the next great extinction event?
In our planet's entire history, there have been 5 great mass extinction events. 5 times when the vast majority of all life on Earth was just wiped out. And what's the common thread? Well, all 5 of them were linked to sudden, dramatic changes in the chemistry of the ocean. And 2 of those events were specifically triggered by a massive drop in ocean oxygen, which created these huge dead zones. The very element this newly discovered deep-sea system is producing. We now know there's a life support system at the bottom of the sea that we never even knew existed. So the final question is a heavy one. In our race for a green future, could we accidentally unplug the planet's hidden electrical grid and, in doing so, trigger the next mass extinction? That is the choice we now face.